Welcome to Bexley Test 1 Exam Papers Plus. Volume should be very good. I'm talking into the microphone. Here we go. Every single question, you can pause, have a go yourself, and then do it. Let's see how this goes. So, question 5. A piece of string is cut into 4 equal pieces. Let's draw that straight away. 1, 2, 3, 4. One of these pieces is then cut into 2 pieces such that one piece is twice as long as the other. Whenever we see that, then we need to split that up. But what are they telling us? The shorter piece is 25. I had to read this twice when I first did this question. Here. So what are they telling us? That bit is 25. Because one of them is cut up into 2 pieces. I'm just going to put that in blue. That's the bit that's cut up. Just one of them, really. So what are we saying? If one of them's 25, the other one is twice as long. That means, what's that? 25 times 2 is 50. Okay, now we've got the question. How many meters long was the original piece of string? The whole thing. Can you see that section? That is 75 because that's 25 plus 50. Okay, well, so what, William? So what? Well, look at this. 1, 2, 3, 4 of these sections. And what are we saying? One section is 75. Write it with me. Have some paper in front of you as we're doing this. One section is 75. So then 4 sections is 300 because that's 75 times 4. 300 centimeters, and with these kind of questions in this exam papers plus, it's just one more step. 300 centimeters is 3 meters. That is the answer. Tick. Question 6. Callie thinks of a 3-digit number. Now, if you are one of my students, normally I tell you if it's a long maths question, just read straight away. Read the end bit. What number is Callie thinking of? Okay, now that doesn't help. We have to read the whole thing. 3-digit number. So just write it with me. We don't know. The unit digit is prime. That means the first number, guys. That is prime. Okay, well, let's look. Which one isn't prime? That one. 9 isn't prime, so that's out. And the hundreds digit is a square number. The hundredths digit, that one is square. 4 is a square number because that's 2 times 2. 9 is a square number. It's 3 times 3. 2, nope. 0 times 0 is 0. Oh yeah, I guess that's okay. What a strange one. Let's cross that off because 2 is not a square number. Hang on, have I messed this up a bit? Please ignore me. It says the hundreds, not the tens. Ignore me. Pretend I know what I'm doing. Hey, but that's part of the process. I'm not going to edit this out because if I misread a question, that's still part of the thinking process. Hundreds digit is square. That's the first bit, guys. Hundreds, is that a square number? Yes. No. We crossed that off already. Yes, yes, yes. Okay, that doesn't help because they're all square numbers. You can see the first one. 1 is 1 times 1. 4 is 2 times 2. And 9 is 3 times 3. They're all square numbers. Her number is less than 600. That should be easy one to get rid of. Less than 600. Thank you very much. A is out. That is 945. And in this one, brown, it's got to be a multiple of 7. That just means it's in the 7 times table. So if you're not sure, just check each one. Just divide each one by 7 and hopefully you pick one. Divide by 7. Job done. Don't even waste your time checking the others. Let's go with the first one because it's there. It is there. Let me put it here. Quickly check. 7 into 427. Does it look like it is in the 7 times table? Do it. Don't be lazy. Do it. How many 7s go into 4? 0, remainder 4. How many 7s go into 42? 6. How many 7s go into 7? 1. So the answer is C. Because it's telling us that it is in the 7 times table, but guess what? It's also in the 61 times table because we've just worked out 427 is 7 times 61. Done. Now, I just want to show you the last one because it's actually pretty close. 102. If you divide by 7, it won't work. But if you divide 7 into 105, it works. quickly do that. Why is William doing this? Because it's just a bit of extra info. It can be useful. How many 7's going to 1? 0, remainder 1. How many 7's going to 10? 1, remainder 3. How many 7's going to 35? 5. So it's 15. So really now you've also learned a bonus feature. 105 is equal to 7 times 15. Good. Next question. Question 7. Diagram shows a right-angled isosceles triangle and a rectangle. What's the maximum number of triangles identical to the one shown that will fit inside the rectangle? Good question. How many of these guys will fit into here? So step 1, we need to match the length with the length. How many 3.5s will fit into 7? Well, that'll be 2. How do we know? Because 3.5 plus 3.5 is equal to 7. It kind of looks like 35 plus 35 equals 70. So we're saying 2 of these triangles will fit here. There's a triangle. Really, really good question. So I will show you the trick very soon. Next bit. How many 3.5s will fit into 17.5? Now, that's not obvious straight away. It is for me because I know about these numbers. We just keep going up the 3.5 times table. Job done. Keep going up. 7 plus 3.5 is 10.5. Why is he saying it like this? Because we can always work out a times table. We just keep adding the number to itself. We keep going and going until we reach that number. 10.5 plus 3.5 is 14.0. Then add again. 14.0 plus 3.5, 17.5. Okay, so how many of these will fit? 5. So we're saying we have 2 rows and 5 columns. So how many shapes in the middle? 2 times 5 equals 10. And 10 is there, and it's like they want you to get it wrong. 10 is not the answer. That's the brilliant thing about this question. I hadn't seen this until I've done this paper. That would be how many squares would fit in. Imagine I could stack it up like this. How best to draw this? Like this. Like that. Here. Here. If it was a square, then what are we saying? Like that. Let me draw it a bit better just to make it crystal clear. I could do it like this actually. 2 along. I could draw a line going down. So what am I saying? 2. 2 of these guys will fit along because we can see from the green. Now what is William doing? I'm just going to copy that a few times. Done, done, done. Imagine I can actually draw it properly. It's like one more here. So what is William saying? Well, how many squares can you see? Triangles. 10 of these triangles will fit in. That's what we've worked out. But can you see 1 square is equal to 2 triangles? So what is William trying to say? If I draw a line like this, I'm just cutting each bit in half. So can you see if you count up everything? I'm just drawing it because I just want to make this as useful for you as possible. Can you see if you count up all this? There are 20 triangles. What's a really, really fast way to count? Look at the top row. 1, 2, 3, 4. 4, 8, 12, 16, 20. Because there are 5. There are 5 rows, and each row has 4 triangles. Let me just write that really clearly, just in case. 1 row has 4 triangles, and so there are 5 rows, so there'll be 20 triangles. So the really, really quick way to get this answer is we know there were 10 triangles, and we just double. I just wanted to show it via a picture. Just wanted to show it with a picture. So the answer is 20. Wow, what a fantastic question. We are now 9 minutes in. It's going to be a short video. Let's make these really short, really concise. Job done. 9 minutes in. It is now 23:35 on Sunday, the 28th of July 2024. My normal way to end these kind of videos is to make the screen dark, and same way in the top left corner will be the previous video, which will be questions 1, 2, 3, 4, I think, in the top left corner. Now when I've made the next video, it will be in the bottom left corner, so then you can keep learning about maths on this channel. Keep going through this paper. Thank you so much. I'll see you later.